All right, guys, 5.2, we're going to start with circles. Hopefully some of this you can remember from secondary 2, because that's where we did a lot of circles the last time. So if this seems brand new, just take your time with it, and then hopefully some things start to come back to you, okay? So a circle with the center HK and the radius, of course, is greater than 0, is the set of all points of x and y in the plane whose distance to HK is r. Of course, that makes sense, right? So we have a center, and the radius creates the whole circle in general, okay? By definition, a point xy is on the circle if the distance to HK is r. Okay, so of course, xy is on the circle only if the distance between HK is r. This helps us prove certain questions later, okay? So we can express this relationship algebraically using the distance formula, which is really just the Pythagorean theorem, okay? So remember, the Pythagorean theorem is a squared plus b squared equals c squared. C being your hypotenuse, okay, and think of that as your radius, right? And then A and B being your x and y from the center. So the idea is the radius is the square root of x minus h squared plus y minus k squared. So remember, keep in mind that h and k are our center. Think of the opposite. Okay, and it's the radius r has to be greater than 0. Standard equation of a circle. So when we think of an equation, so like linear is y equals mx plus b. I mean, there's other linear equations that we can think of. A square or a parabola is x squared, y equals x squared, so on and so forth. The equation for a circle is x minus h squared plus y minus k squared equals r squared. Now, this is very important. Remember that when you do the equation of a circle, of course, h and k, you got to think of opposite, right? But here's the biggest part where people mess up. This number at the end is not r, it's r squared. So watch out for that stuff, okay? So what we're going to do right now is we are going to put these things, so we have a center here and radius, in an actual equation here, right? So I'm going to do this little by little. Some of you might skip these steps, but I'm going to show you in each piece. So we have x minus, and then our h is -2 squared plus y minus our k, which is 3 squared, equals our radius, which is 5 squared. Again, most of you might have been able to jump right to the answer, but I'm using step by step so you can see this. So of course, x minus -2 is x plus 2 squared, plus this would be y minus 3 squared equals 25. So again, this is what I say opposite. So instead of -2 here, we have +2. Instead of 3 here, we have -3, and our radius is squared. Okay, so I wanted you to see that step. All right, next page. Okay, find the center and radius of the circle given by the equation x plus 2 squared plus y minus 4 squared equals 4, and then graph the circle. Okay, now this is already in our form, right? So remember, this is x minus h, this is y minus k, and this is r squared. So that means that the center, which is HK, is -2, 1. And the radius, keep in mind that we have to think of this as squared. So what's the opposite of square? We take the square root, so the radius is 2. Now we're going to graph it, guys. So of course, the first thing we're going to do is plot our center, which is at -2, 1. And then a radius. Now, of course, I am not the greatest at doing circles, but I know a radius is 2 away from our center, right? And then you get to draw a nice circle, which, yes, mine is not going to look so much like a circle. Actually, I did pretty good right there. So on and so forth, right, guys? Okay, if we were to expand the equation in the previous example and gather like terms instead of the easy rectangle, you know, this center and radius, we could actually be looking at a standard equation, okay? But what if we started this? Okay, so let's think of this. What I just said, if you're still confused right now, this is our standard circle equation, okay? Because it has the center and the radius. But if I were to expand it by squaring this out, and moving everything to one side, this is what we would come out with. So we also have to say is, what if we started with this? How can we get here? And what we do to do that is to complete the square, okay? That's what we need to do, is complete the square. Now, many of you have other ways of completing the square. I'm going to do it what I think is the easiest way. So try to follow me. If you have another way and that's the way you prefer, go for it, okay? Now, there is a misprint here. This should be a -4, okay? Because the first thing we are actually going to do is add 4 to both sides, okay? This is supposed to be a minus here, okay? -4. So we're going to take the constant. So the first step is to take the constant and move it to the other side. So you get 3x squared minus 6x plus 3y squared plus 4y equals. Now again, if this was supposed to be a -4, I move it to the other side, I get a +4. Okay. Now, here's the thing also. If this wasn't already in the order, you want your x's together and your y's together. So if it was all in between, I would automatically do x squared x and y squared y. Okay. Next, what we need to do is when you complete the square, you want the coefficient, the number in front of x squared and y squared to be 1. So what we're going to do is factor that out. So I'm going to factor out a 3 to the x's, and I get x squared minus 2x. Okay, and then I'm going to leave a space. Plus, I'm going to factor out a 3 here. I get y squared plus, I factor out a 3, I get 4 over 3 y, leave a space, equals 4. Okay. Now let's keep in mind to find the other term, the third term, to make this a perfect square. Remember, a perfect square looks something like this, where I'm having x plus 2 squared. This is perfect square. Okay. Way to do that is to take your b value, divide it by 2, and square it. Okay. So right here, our b value is -2. We're going to divide it by 2 and square it. So -2 over 2 is -1. -1 squared is +1. Now, what I'm going to do is underline this to keep this in mind that we're placing that in there. Okay. On this one, we have 4/3 divided by 2 squared. This is a little tricky, right? Because you got to think about this 4/3 divided by 2 would be 2/3. 2/3 squared is a positive 4/9. Okay, perfect. Okay, again, I underlined that because we're placing that in. Because here's the thing, whatever we do to one side, we must do to the other. Otherwise, I have a new equation. We want to keep it the same. So I just put these in here. So I also have to put them on the other side. Now, what that means is I put in a 1 here. But how many 1s did we put in? We put 3 of them in there. So I'm going to add 3 1s. Okay, that's where that came from. Now here, I'm going to add 3 4/9s. That is the tricky part, guys. A lot of us tend to just put in the 1 and the 4/9, but we are actually putting in 3 of them. Okay. Now let's gather everything together. We can put this into our perfect square, and add these together. So I have 3 times. Now, how do I know what this is going to be? Well, this value, guys, will always be the b/2. So -2/2 is a -1. This is squared. That's why we're making a perfect square, right? Plus 3 times y. And again, what was that? 4/3 divided by 2 was 2/3. And it was a positive 2/3. Now, do this all on your calculator. Oh, I just made my pencil fly. Sorry, guys. There we go. If I add those all together, I end up getting 25/9, which makes this equal to, remember, our center is HK, so H is 1, K is -2/3. And be careful on this radius, because remember, the radius is not 25/9. We have to take the square root, which means the radius is 5/3. All right. What are other questions that we can be asked? The good thing about this lesson is that we're getting examples of every type of question, okay? So always refer back to the example of that question. Here we have, write the standard equation. So again, we want to look at the x squared plus y squared equals the radius squared. But the idea is that we have it, the circle goes with this xy and this xy. So if you picture it, these 2 points are on the circle. Well, if those 2 points are on the circle and we know they're ends of a diameter, right? How do we find certain things? Well, let's think of it. In a standard equation, we need the center, right? You need a center. How do you find the center of a diameter? Well, to find the center of the diameter, we find the midpoint. Right? Now, if you relate back to all those years of math in the last 3 years, how do you find the midpoint? Well, the midpoint is your x1 plus x2 all over 2, because we're dividing it in half, right? It's like the average. And then our y1 plus y2 over 2. So you're taking the average of both. So let's do that with our 2 coordinates right now. So we have -1 plus 2 divided by 2, comma. We have 3 plus 4 divided by 2. So that means our center is 1/2, 7/2. Okay, that's great, right? That means what we have so far in our final equation, and I'll start writing that right now, is we have x minus 1/2 squared plus y minus 7/2 squared equals, so what are we missing? Okay, we're missing the radius. How do we find the radius? Well, think of this. The radius is half the distance of the diameter. Okay, so what's the distance formula? Well, let's keep in mind the distance formula is x1, or we could go either way. Either way is fine because we're squaring it. x1 minus x2 squared plus y1 minus y2 squared. And remember, in this case, we're taking half of it. So I'm going to multiply it by half. So now let's plug in those numbers. Get 1/2 square root -1 minus 2 squared plus 3 minus 4 squared. Does everybody see why it doesn't matter if it's x1 or x2? Because since we're squaring it, no matter what, it's going to be positive. Most mistakes that people will make at this point is if we had a negative, they would forget to say minus negative. So be careful on those. And then if we plug that into our calculator, we get a decimal, right? So we really don't want a decimal. So let's break that up even more. Because we want to do it exact as we can get, okay? So no calculator at this point. As you can see, decimal didn't work very well. Or you could change it into a fraction, but I'll do it the longer way. So if I do my square root, I get the square root of 10 over 2. Well, I'm going to put the whole thing in a square root, okay, guys? So if I put the whole thing in a square root, I would get the square root of 10 over 4, because this is the 2 is not in a square root, so to make it into a square root, it would be the 4. Okay. Now, of course, this is the radius, but when we put it into the equation, we have to square the radius. Well, if we square this, right, what happens? Oh, they cancel. So our value is 10 over 4. Okay. If you need me to explain that more, make sure you ask next class. Okay, last question. The unit circle. Many of you might recognize this from trigonometry, right? We did the unit circle in secondary 3. So with the unit circle, the center is 0, 0, and the radius is 1. So that's why we get the equation x squared plus y squared equals 1. So if we want to find the points on the unit circle that have the y coordinate of square root of 3 over 2, what we have to do is plug this in for y and solve. So let's do that right now. We have x squared plus square root of 3 over 2 squared equals 1. All right, let's do this together. Get x squared plus, well, the square root of 3 squared is 3, and 2 squared is 4 equals 1. Subtract 3/4 from both sides. I don't know, I said 3 and then I wrote it. X squared equals, if we go, let's see, 4 over 4 minus 3/4 would be 1/4. How do you get rid of a square? Well, we take the square root. Now here's the tricky part. Just remember this. When you take the square root, how many answers do we actually get? We get 2. We get plus or minus. Okay. So when we do the square root of this, we get x equals plus or minus 1/2, right? Because square root of 1 is 1. Square root of 4 is 2. Now be careful. We are not done because the question asks, find the points This is not a point. This is the x value. So our final answer is 1/2 square root of 3 over 2 and negative 1/2 square root of 3 over 2. And yes, those are coordinate pairs on the unit circle. All right, guys, that's it for circles right now.